Hello everyone, and welcome back to another video, and today we will take a look at the GTX 980 Ti G1 Gaming / Windforce PCB from Gigabyte. Why are we doing that? Well, I just bought this card. I did not get the card in a working state, however, because this is dead, 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 and that transistor is knocked off. So yeah, once I'm back home, this card is gonna be very fun to repair because the only issue is actually here. This was caused by someone who tried to repair the card and had no idea what they were doing. And of course that wasn't mentioned in the listing. But yeah, it might still be fixable. It's just going to take a lot longer and require a lot more effort. But anyway, I do want to take a look at the PCB, not because it's all that special. We already did take a look at the 980 Ti Extreme Gaming from Gigabyte, which is the extreme overclocking variant of this card, which is much better. But I kind of always wanted one of these. Like, I was a big fan of the 28nm, like 3-than Windforce cards from Gigabyte. I did run a 780 Ti Windforce for over 4 years, and if I didn't have, if I wouldn't end up with a 780 Ti, I would have ended up with this card. So, yeah. Anyway, let's get into the PCB. So this card is not the most powerful card by any means. Actually, it has a Vcor Vrm that looks very familiar because we've seen it before on 2 separate cards. So this is a 1, 2, 3, 4, 5, 6, 7, 8 phase. And it's controlled by this thing right here. That is an NCP 81174. This is running in 4-phase mode. So how do you get 8 phases with a 4-phase controller? Well, of course, you use doublers. And this is kind of a weird decision if you're asking me, because the 780 Ti Windforce was also an 8-phase, and that one just used an NCP 4208, which is a native 8-phase controller. So you could ask, why is Gigabyte gigabyting? But actually, this time it's not their fault. It was their fault on the 10 series, because there they had an UP9512 or UP9511, which they could have used. But actually, this controller and doubler config is also on the reference card. So the reference 980 Ti is a 3x2 phase, and this is a 4x2 phase. So yeah. And by the way, the doublers are the NCP 81162. Those things. So yeah, these are doublers. So we have a 4x2 phase Vcor. Then the power components for our VRM are the FDMF 6823C. This is a 50 amp, oops, not 5 amp, that would be a bit bad, 50 amp DRMOS. And so this power config is very familiar. We've seen it before on the GTX 780 Jetstream from Palette. The same PCB is also used by the Gainward Phantom. I believe they also reuse it for the 780 Ti. There's also a 980 from Palette and Gainward that uses that VRM. There might even be a 980 Ti from them that also uses this VRM. Gigabyte is also using this VRM on the GTX 1080 Ti gaming OC. Now, of course, between all of these cards, the controller and doubler, whether they exist or not, config changes a little bit. Like the cards that I mentioned before, I think are all on an NCP 4208. The 1080 Ti is on a UP9511, but it does not change that we have 8 phases of FDMF 6823Cs. So yeah, and this is technically better than reference. The reference card is a 6-phase. However, it does actually also have 8 DRMOSes. So the reference 980 Ti, just like the reference 780 and 780 Ti, have 2 phases where there's 2 DRMOSes in. And those are mainly used for input current balancing, because one DRMOS is on a different 12 volt source than the other. And by choosing to either use one or the other DRMOS, the card can balance how much current it is drawing from the various power inputs. But theoretically, it could also use these 2 DRMOSes at the same time to double the current capability of 2 of its 6 phases to exactly the same as this VRM is capable of. However, I don't think the card is specifically doing that. It might be doing it a little bit, because like you basically never see those 2 phases blow up. So the card is involved in some spreading the load between the 2 DRMOSes, though I like, as far as I know, it's mainly for current balancing and less for increasing the power handling capability of the VRM. Whereas on this card, we just have a straight up 8 phase, we don't have any weird phase configurations. So yeah, so 8 times 50 amps. This VRM would be adequate for like a 1080 Ti or like a 980, slightly less adequate on a 780 Ti or a 980 Ti. So yeah, this is not the strongest VRM ever. 980 Ti's, especially if you put them on liquid nitrogen, are very, very power hungry. I like, Buildzoid had an E-powered Titan X Maxwell, which is basically a 980 Ti with more VRAM and a few more cores, and he had it E-powered on an EVGA E-Power 5, and as far as I know, while he was streaming it on LN2, he actually hit the overcurrent protection of the E-Power, and I think he was at like between 1.8 or 2 volts Vcor output. So 980 Ti's on liquid nitrogen are incredibly hard to feed power. Like, I mean, they tripped the OCP on an E-Power 5. That's a 12 phase with 60 amp smart power stages. Coincidentally, that's also the exact same VRM that the 980 Ti Strix uses. And then Gigabyte's own 980 Ti Extreme Gaming also has a 12 phase, but also again with FDMF6823Cs, these are slightly less fancy and only 50 amps. Then I think the Kingpin is also a 12 phase. I don't know what power stages that one uses. And then there's like the Hall of Fame, which is a 14 phase. That's like the one card that's more powerful than that. But I think every other high-end 980 Ti pretty much has a 12 phase. I could be wrong, but I think pretty much every high-end 980 Ti has a 12 phase. And this is on an 8. So for running the card daily and like doing some slight overclocking on water cooling, this is probably fine. But if I was to repair this card and run it on phase change cooling, which I would probably try anyway, but there is a high possibility that the VRM is not going to be able to handle it. Now I have 2 cards that I like, well, I have one card that I'm pretty sure it's dead. I have another card that needs a memory module swapped. Both of these have 8 of these FDMF6823Cs on them. So if this VRM should blow up, I think I'm just going to cannibalize those cards, or at least the one card where I'm pretty sure it's dead. So I can handle a few Vcor meltdowns, but, you know, of course it's not ideal to have that happen every now and then. So yeah, it's not the most powerful VRM. It is better than reference, but in terms of how much current you can put through it, it's not all that great. So memory VRM then. So our memory VRM is a 2-phase, and we have some dual NFETs in this VRM. And these dual NFETs, I first thought they're like Fairchild because they have like an F on them, and it seems that they are, but the datasheet I found for them actually states that they are on semiconductor parts now. And these are FDMS 3604Ss. These are dual NFETs. The well, I'm not entirely sure. Well, actually, I think I know which is the high side. So the high side has 8 milliohms of RDS on at 10 volts gate to source voltage and can handle 13 amps. The low side has 2.6 milliohms RDS on at 10 volts gate to source voltage and can handle 23 amps. 23 amps is not all that much. And if you remember correctly, this thing died. You can actually kind of see that there's like a bulge in this area, and like these two bridge resistors burnt out. That's because this MOSFET failed. This happens a lot on these cards. Like the 980 Ti G1 is kind of known for having two things fail quite a lot, and that is the memory VRM MOSFETs and also sometimes the core VRM, the RMOSes. Now, as far as I know, the memory VRM failure is far more common, but if you run this card in like a case with bad airflow and don't set a custom fan curve, you can probably also end up in a situation where you're overheating your Vcor Vrm and it might blow up. Because I have seen a few cards that needed the FDMF 6823Cs swapped. So yeah, but memory VRM is a two-phase, and your memory controller sits right here. And this thing was extremely painful to find out what it is, because the marking on the chip itself is L1172. And I tried Googling that and found nothing. And then after consulting the Actually Hardcore Overclocking Discord, I quickly found out that the L just needs to be replaced by an 8, and then you end up at the NCP 81172, which is a two-phase controller. Which, of course, makes sense for two-phase memory VRM. So that's the controller. So if you want to volt mod it, look up that one, look into the datasheet, and you'll find out what it does. And that's pretty much it for the memory VRM. No doublers, just like it's a memory VRM, pretty simple. Then for minor rails, we have something here. I would guess that this is a gate drive. So this is probably going to be outputting 5 volts or 7 volts. I don't think that they run these at 10 volts gate to source voltage. So actually, like, those ratings I gave are not all that adequate. But like, it's only rated for 10 volts or 4.5 volts. If this is putting out 5 volts, this thing is actually a lot worse than what I put down. I hope this is running at least 7 volts, is what I'm saying. Yeah. Then here we have the Pex Rail. So if you're overclocking this card on liquid nitrogen, or pretty much any card on liquid nitrogen, you probably want to volt mod this rail, because it can help with you know, like cold bugs, cold boot bugs, display dropout issues. But pretty much only on LN2. On phase change, you shouldn't have to touch this. There's some cards where you have to, but NVIDIA cards are usually well behaved. So on anything that's not liquid nitrogen overclocking, you really shouldn't have to touch this rail. So yeah. Then we have two more little things here that are called APL something. So that usually indicates that they are like low dropout regulators or small single phase buck converters. What these do, not entirely sure. This one might power these display switches, because the card has a display switch feature where you can toggle between having an extra DVI or 2 extra display ports. It might not be powering those. As far as I know, some 980 Ti's actually have an onboard 3.3 volts low dropout regulator, even though like you're getting 3.3 volts right here. But for some reason those cards have an onboard 3.3 volt regulator. So I'm just gonna put down 3.3 volt question mark, and this one might be either 1.8 volts or 5 volts. Probably 1.8 volts, because like well, actually on GDDR5 the 1.8 volts rail is still internal, On GDDR5X and newer, it's external. So the only thing that really needs 1.8 volts on this PCB is the BIOS chip on the back. And Gigabyte could have totally just chosen to use a BIOS chip that runs on 3.3 volts instead. So this doesn't absolutely have to be a 1.8 volts rail. I think it is standard to include one for the BIOS chip, but you could theoretically use a different one, and this might be like a 5 volt rail. Or maybe this is a 5 volt rail. Like, yeah. So these two, like, you would probably just have to kind of probe around and find out what they do. It's not really critical to know what they do unless they die, in which case you would be probing them anyway and figuring out if they're dead. Like, you don't have to do anything to these when overclocking. Like, all the overclocking interesting stuff is on the right. So yeah. Then on the back, we have this chip, which is part of the Pex Rail. We have the BIOS chip. And only really output filter is the only other thing that we can see on the back. Oh no, actually, there's two current steering MOSFETs here. These also apparently tend to burn out on some cards. On my card they are okay. But these are a similar idea to the 2 power stages that NVIDIA used on the reference card in one VRM phase. Basically, as far as I know, these are supposed to switch certain VRM phases over to a different 12 volt input, again to power balance the power inputs. And these sometimes burn out. So, yeah. Then, let's talk capacitors. So, this output filter is actually surprisingly good. Like, this actually looks kind of like a RTX 30 series Founders Edition card, where they just have 2 rows of capacitors just like packed in there, and then even more on the back of the card. Now the output filter for Vcor, and actually also the memory on this card, is entirely made up of SMD aluminum polymer capacitors, which is cool because those are better than CAN type capacitors. Now I would have kind of wished they would have some multi-layer ceramics. Like they even had a pretty easy way. So like, because you can see there's like power plane splits here. So this is ground, this is Vcor, and this is a part of the memory power plane as far as I can tell. But you can see there's like, oops, what just happened to the tablet? I love it when this happens. But yeah. You can see like this sort of stitching, which is from the front part, because you can see it goes right up against the memory modules. So this stitching exists anyway, so there's not really a reason to extend the memory VRM like power plane any more than like this. So what they could have done is replace this stretch of memory power plane with another ground plane, and then they could have had a row of like multi-layer ceramics here, which would have been cool because like all SMD polymer is better than all CAN type, and there are cards where you can get that. But like multi-layer ceramics plus SMD polymers is even better than all polymers. And they, like, theoretically had enough space to do that. Like, at least just give us the pads to do it. Oh, and again, there's, like, they easily could have also, like, put extra pads in between these. Like, that's basically a perfect fit. They decided not to. Like, you know, I was kind of like it when the engineers leave up some stuff for you to upgrade. Like, I'm not asking that they double the amount of capacitors that this card ships with. I would just find it cool if they had some empty capacitor pads that you could just choose to populate yourself. Like, you can actually do that on some of the lower end Asus cards. They tend to just have empty capacitor pads, and you can just like put them there. Actually, the 780 Ti WindForce also had that for like a row of multi-layer ceramics, exactly like I just described, but on this card they chose to put more SMD polymers on the back. So yeah, like all in all, this is a quite nice output filter. Like this is, yeah, this is a pretty nice output filter. I like this. This is like, it's not that much better than the reference card. It is a little bit better because the reference card doesn't have nearly as many capacitors on the back, and the reference card is like the memory VRM right in this area. So that part of the output filter is not actually core. So this is better than reference. It is probably slightly worse than like the Extreme Gaming from Gigabyte, just because that PCB is also just a lot bigger. But like as far as they could have gone on like the standard size PCB, like on the front they pretty much used up all the space. On the back, yeah, they could have had some extra pads, but like honestly that should be enough filtering for like this card. Like that looks like a lot more than you would have gotten on the 780 Ti. And yeah, the 980 Ti does pull more power than that, but not that much. Like the difference really only comes to show when you're like massively overvolting the card. At stock it's like, well, maybe 50 watts difference. So yeah. But yeah, I like the output filter. Now the memory output filter is basically the same that Gigabyte always used. Like, yeah, basically the same. Not much to say about the memory VRM. The one thing that I could say is like the distance. Like it's quite far away. This is not the only card to do that. Like MSI's Lightning cards or EVGA's classified and also Kingpin cards did this just because the core VRM is a higher priority and it needs all the space, so they move the memory VRM back a bit, which adds some distance and adds some resistance and some inductance between the output of the VRM and the memory chips, which can theoretically lead to worse overclocking, but in reality it's probably not that big of a difference, especially because GDDR5 does not pull that much power. So yeah, like the thing is, you can counteract a voltage drop by just having a higher output, which is exactly what most of the cards do. Like I remember measuring this on a GTX 580 Lightning, and it's supposed to have 1.5 volts, and it's outputting like 1.556 or something like that. So that once the power gets to the memory chips, that's actually at 1.5 volts. So yeah, I don't really think that the memory VRM being moved back is such a big issue. So yeah, I think this is fine. And then one last remark to the capacitors. These all of them are 330 microfarad. Now, it could have been 470s instead. Actually, they did use 470s on the memory. But like again, just the sheer number of capacitors is pretty high on this output filter. And the thing is, high capacitance isn't everything for capacitors. There's also ESL, which is a quite major factor. There's also ESR, which is still a factor, but less so than ESL. And the lower your capacitance is, the better these characteristics tend to be, as far as I know. So if you can just fit more capacitors, it's sometimes actually better to have a lower capacitance than going with a higher one. So I think this is mostly fine that they used 330s here, just because we have enough. But yeah, you know, you could have replaced some of these with 470s, I guess. And then actually in typical Gigabyte fashion, we also get some upgrades around the core area. Mainly we get 560 microfarad capacitors directly behind the core. So usually cards have 330s or 470s here. Gigabyte is giving you 560s, and actually they've been, well, I don't know when they started. My 780 Ti had it, the 1080 Ti has it, my 2080 Ti has it. I don't know if their 30 series cards have it. But yeah, like basically for a couple of generations, Gigabyte would give you higher capacitance directly behind the core. Which is nice. So yeah, that's potentially making overclocking better. And they also do this. So you might know how usually NVIDIA cards have 8 mounting holes, like where I just marked. and you pretty much always only use 4 of these. So Gigabyte decided to fill in the unnecessary mounting holes and use them for extra Vcor filtering. So on both sides, both on the back and on the front, they put some multi-layer ceramics where the screw hole would be, which is further Vcor filtering. And this is a pretty cool thing, because this is basically the closest you can put your capacitors to the core, because like in this general core memory area, the board partners are not really allowed to customize anything. Like NVIDIA just kind of mandates what this area has to look like. So you can't really put capacitors any closer than just outside of this area to have better filtering. But using the screw holes instead of screw holes having extra filtering there is one of the minor ways on how you can bypass that, in addition to just giving you better capacitors. So that is cool. They actually they did not do this on the 780 Ti. They did do this on the 980 Ti's. I don't know if they did it on the 10 series, but my 2080 Ti also has this. So they did it for several cards, not just the 900 series, which I think is cool, because that is very close to the core. Like that is extra filtering very close to the core, which, like, the closer to the core you are, the more effective your capacitor becomes. So yeah, again, this can potentially lead to better overclocking. Now, it's not going to be a massive difference because it's just a few multi-layer ceramics. But actually, this is like 16 capacitors total. That's nothing to scoff at. That's like a decent number of multi-layer ceramics, actually, that are pretty close to the core. Like, yeah, like this might actually help you, like, well, 10 megahertz maybe. Like this and the 560 microfarad capacitors might be worth like 10, 20 megahertz. I wouldn't be surprised if, like, on average, if you tested like many cards, on average this one would clock a little higher, given the same conditions. So, yeah. So all in all, like, there's some nice things about the card, like the customization of it around the core. The output filter is quite nice for this class of card. And then there's things that are not so nice, which is like that the memory VRM tends to blow up, the core VRM is kind of underpowered. For some reason they chose to have doublers, which, you know, like, having doublers is always worse than not having doublers. Like, doublers are a perfectly valid way of getting more phases, but if you can just get a higher phase count controller and not use doublers, that will always be better than using doublers, because doublers introduce a slight delay to your PWM signal, which makes your transient response worse. That's actually the reason why Asus opted to just ram a PWM signal into 2 phases and then just have them be like one massive phase instead of using doublers, because they cited that using doublers would have made transient response worse, and so they still put the extra power stages on the board to have the extra current capability, but they're not actually doubling the phases. They just give you like what they call like the team configuration thing. And this is what more and more people are doing, mostly because like very high phase count PWM controllers are becoming more and more available, and doublers are being like less and less produced because they become less and less necessary. Like, if you have a 14 phase controller, you don't really need doublers because that's enough phases for pretty much everything. And then also there's the transient response penalty that doublers give. So yeah. So yeah, they could have just used an NCP4208 on this. Like, this is not Gigabyte's fault. This is just the NVIDIA spec for the 900 series, because the reference card uses this exact same setup. It just has 2 less phases. But yeah, it's a bit bizarre because they had this figured out last gen and then they chose to just kind of throw that away. So yeah, it's a bit of a mixed bag. Like, mainly I got the card because it was kind of cheap and I thought it was gonna be an easy fix, and it would have been if someone I bought it from wouldn't have ruined like half the memory. Which will make this repair a lot easier, and maybe not even feel like, if I have to buy new memory chips, I'm just not repairing the card, because new memory chips cost about as much as I paid for the entire card. Like, I'm just gonna wait for another cheap 980 Ti at that point. Especially because this is also a Hynix card. Hynix cards are not as good as Samsung cards for overclocking. Like, it's pretty much only an LN2 thing. So like, once you go cold enough on 980 Ti's, you eventually have to increase your memory voltage to keep the core stable. And the Hynix modules have negative voltage scaling, so basically they stop working if you increase the voltage. So if you have a Hynix card, you can't get the most out of your core because you at some point need to increase your memory voltage to keep the core stable. Which you can't do on these because the card will just stop working. So yeah, that kind of sucks. So I'll be seeing if I can repair it. Like, basically I remove the 5 messed up memory modules, I'll clean the pads, resolder them, and then hope that it works. If it doesn't, then, well, I guess it's gonna become a wall ornament, or maybe an e-power. Like, this VRM could e-power like a 680 or something like that. Maybe I'll turn it into an e-power, I'll see. But for now, yeah, that's the GTX 980 Ti G1 Gaming from Gigabyte. Yeah, it's nothing exceptional. It has some nice upgrades over reference, but you know, it's nothing exceptional. I just wanted I just saw a cheap 980 Ti that's probably an easy fix, and I went for it, and yeah, that's why I have the card. And now I gotta deal with it that someone messed it up. Anyway, so thank you for watching, hope you learned something, and until next time, goodbye.